Oh, there you go. All right, let's go and do that again. Well, welcome, ladies and gentlemen. I must have somehow hit my mute. So thank you so much for getting that. So thank you so much, ladies and gentlemen, for week number 46, open number Q&A. My name is Brian McLogan, and thank you so much for joining me this evening. You should be able to still hear me. Can't hear me. What the? All right. It should be going now, so let me see. I can't hear you. All right, well, hold on, guys. It's only a math teacher like. There's still no. Get this audio going. Hold on a second here. Still nothing, huh? Oh, well, hold on a second. Hello. Seems to be going through. We can hear you now. Okay. All right. Weird. So I guess maybe that's also my delay. So, all right, guys, I'm going to go through my whole outro or my intro one more time, just because what I'll do is I'll be able to replay this and I will cut off that first version, which was the awkward part. So, and then also, I don't know who heard it or not. So we'll just go through this beginning. All right. So we're going to start all over again. We're going to pretend that first part never happened because somehow my audio got hit to mute and I didn't see it. So, all right, here we go. All right, welcome, ladies and gentlemen, to week number 46. This is Open Q&A. My name is Mr. McLogan, and thank you so much for joining me this evening, where I am here to answer your questions. And these are the questions that you guys have pre-submitted to me on my Google Forms, which is in the description down below of this live stream. So if you would like for me to answer your questions, then feel free to go ahead and submit a question into that form. I do already have roughly around 20 selected problems for tonight. But one of the things I want to do a little bit differently for this live stream is I want to make sure that I have an opportunity for you guys to answer some questions or me to take some of your questions that come in through the live stream. So, I don't have any topic that I'm going to cover in this live stream. You know, we have a shortened week in the United States. We have Thanksgiving coming up. So we don't have like a major test or exam impeding this week. So I thought it'd just be a great opportunity that if there is some questions that you guys have, I can go ahead and join them. So as we're going to work through the questions, I do have a couple spots where I can answer your questions as well as just say hi, to like Renee and Lisa and Toxic Plays, and for you guys joining, because I really, really do appreciate it, you guys joining into my live streams. And I want to make sure I just kind of take some time to stop in the live stream and just say hi. And then as well, if there's any questions that maybe I might have missed, then you guys can go ahead and submit those questions as well. However, tonight I went through roughly 60 questions. And so you got to understand, I don't have a lot of time to, one, screen the questions, two, to kind of like mentally think or work through the questions. And, three, to also like read and like, go through them. Like we're doing 30 questions. So try to keep these rather simplistic and I'll try to do my best that I can. However, lastly, just wanted to let you guys also remember, if you are taking an exam, in the next couple weeks, I do have an exam checklist that's also in the description down below. That is a free download for you to kind of use, just kind of see, what are some things that you can do to help prepare for your semester exams. And then also I have something a little bit extra and bonus for those pre-calculus students. I do have a little extra kind of mini course that I have a part of my pre-calculus course that involves the semester exam as well as final exam. And that covers my actual exams that I have for my students, as well as their semester exams and not semester exams, but they're also reviews as well. So that is something that you guys can look at if you're interested in. It's, again, the links are in the descriptions. All right, so Jay and Cody, I see you, and Marcelo, Addie as well. Thank you so much for joining in. BMS, I got a math test right before Thanksgiving. Rough. Actually, I'm giving a test actually as well to my students. To my Algebra 2 kids, I'm giving a test. For some of you guys, what I'll do is I'll give you guys a little bit of tip and hint once I get to my open, and then whatever kind of question that kind of pops into me, I'll be able to go to. But obviously with, so many questions and so far in advance here, I'm not going to be able to remember, so many of your questions that you guys have. So, but thank you so much again, guys, for joining in, and I will see your chat. So, man, I got Lana and Angeline and Carlo, and just don't peek, Mr. Lauros, Alicia, Journey, Thank you so much, guys, for joining. All right, so what we're going to do is typically the way that this kind of works is I roughly have about 3 questions that I'm going to cover. And then after that, I kind of have like some open questions. And actually, we have a little bit of room. So then I have just a little space where I can just answer another question that goes on. And then what I'll do is I will move on to, I'll answer, giving question from you guys inside the chat. So once I get to finishing a question and taking a break, I get to these open, then feel free, if there is a question that you guys have, then submit it at that time. Obviously, if you guys have questions throughout the chat and you want to put them into, or throughout the live stream, you want to put them into the chat, then feel free to go ahead and do that. And if you guys can help each other out, I always enjoy that. I also have a Discord server where you guys can post your questions and help each other out from there as well. So, all right, ladies and gentlemen, I am going to kind of work through these a little bit rather quickly than I have done in the past. And the reason being is just because we have so many. I've never attempted to do 32 questions within a live stream. So that's a lot. So we'll see what happens. Because even after like doing 10 and 15, my brain already feels fried. So we'll see. All right. Journey, yes. Hi, I said your name. Kamslam, Ahmed, Ethan, thank you so much. Website do you recommend would be best to assist in trig and calculus? I don't know, my YouTube channel. There's a lot of, I don't have any really formal recommendations from there, but let me focus in here. I'll get to you guys in your chat in a second. All right. So in this first one, it was just generate the first 4 terms. And so in this one, it had a, so again, just remember this is a geometric sequence. So the formula for the geometric sequence is going to be a sub n equals a sub 1 times, times the ratio r of n minus 1. So all we're simply going to do is, again, this is going to represent your a sub 1, and I believe the multiplier is going to represent our ratio r. I've never seen it used as a multiplier, so that's what I'm assuming that's going to be r. So, and typically in this case, that's all we're simply going to do is plug in your first value. So let's just work on this first one. It doesn't matter really what these numbers are. All you're simply going to do is be taking those values. I'm going to believe the square root of this. If you want to find the a sub 1, then you're just going to take that first term, 3, which is your first term, and then your multiplier, r, times 1 minus 1, which is obviously going to be 0. Anything raised to 0, and that's going to be 3. And then you can just do a sub 2. So that'd be 3 times 2 raised to the 2 minus 1, which equals 3 times 2 to the first power, which equals 6. And then you can just keep on going on and on from there. So dot, 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 and you just kind of keep following that pattern. And that's basically all you're going to do when you want to generate those first 4 terms of your geometric sequence. Yes, I do like Symbolab and Photomath. Those are always good. All right, the next one says the graph has the axes removed, and the graph shows that these 7 functions match each function to its graph. So I thought this one was kind of interesting because actually I like this question because basically, rather than just like identifying what the function is, you have to like realize which 2 equations they could be, right? I mean, like what are the commonalities? What are the differences? Because basically it's just a linear and a quadratic. So in this one, I see I only have one negative linear equation. So I'm looking at which one's going to have a negative slope. So that's going to be a negative x, right? And I see this one. So that's going to be e, right? Because that was the one that has the negative slope. I also see an upside down parabola. That means it's going to have a negative a. So that's going to be this one right here. Has a negative a. Let's actually put these right there because I have a little room. All right. Then the next one, y equals 2x plus 3. Okay, so now let's go and look at, now we have these 2 linear equations, and then we have one that's a little bit slower. So if I look at the 2 linear, I have 2x plus 3 and 2x minus 2. And then obviously those have the same slope, so that has to be, I'm assuming, b and f. And then the one that has a slope that's a little bit less, like it's not increasing as fast, is c. So that one has to be that, because 1/2 up 1 over 2 is not going to increase as fast as up 2 over 1. So then I got to determine which one is these, right? What's the difference between these 2? Well, obviously plus 3 and minus 2. Plus 3 is going to have a higher y intercept than the negative 2. So I say which one would be higher? Like if I did have the axes right here, you could see that b is higher. And then what is that, f, I assume? F is going to be lower. So now we get into the quadratics. So we'll call that B, and we'll put the F right there. All right, so the quadratics, we already found the negative, so now we just got to look at between these two. Now, I don't know which one is going to be higher, the x squared plus 1 and this one because it's in standard form. So one thing you could do is you could complete the square to see what that would look like. And so if you completed the square, I'm not sure what you know on quadratics, but if you completed the square, basically taking your middle term divided by 2, which would be a -5, squaring that, which would be a positive 25. And then if you subtracted 25, then you'd get a y equals, this gets factored down to an x minus 5 quantity squared minus 4. Okay, so now we're going to compare that to the minus 4, which is going to shift it down 4 to the plus 1. And so you could say that one's definitely G, and then this one's going to be, I don't know what the, oh, D right there. There you go. All right, very good. All right, so then the next question. Oh, and also, by the way, I just want to let you guys know, if I do get to your question, that one of these pre-submitted questions, or if you're bored and you don't want to stay any longer, you can always go back and revert to these live streams. You know, I go live every Sunday, but sometime throughout this week, I will make sure I put the timestamps for all the questions. So if it is something that you do need to go, and you know, depending on where you live, if it's early in the morning or really late at night, if you can always come back, I do have all these questions timestamped. So therefore you can find the exact question that I solved and when I solved it on the live stream, because, you know, obviously this live stream will go long. Or all my live streams on Sunday usually go at least an hour. So that's always something you guys can go and do. All right, so the diagrams shows the entrance to the road of the tunnel, okay? And then it says calculate the perimeter. So a couple things we need to understand about the perimeter is we need to be able to identify this arc, right? Well, that is going to be our arc length. And so the formula for arc length is S equals R times theta. But it's very important to understand that theta needs to be in radians, okay? So therefore, we need to understand, well, how do we convert from radians to degrees? Well, if you have a R in radians, then all you're simply going to do to go from radians to degrees is you're going to multiply, or if I have a theta in radians, then all you simply need to do is multiply this by 180 degrees. I'm sorry. 180 degrees, if that is in, oh, I'm sorry. Oh, idiot. If we have a degree in degrees and we want to convert it to radians, all we're simply going to do is take theta and multiply it times pi over 180 degrees. Okay, so that's basically what we're going to simply be doing, is taking our value, our angle here, if it's in degrees, and if we want to write it in radians, we're just going to take that value and multiply by pi over 180. So I don't have a calculator. Well, I do have a calculator, but I'm not going to do my calculations for the sake of everybody's time of not watching me plug numbers into my buttons. But I will help you with that. So this is going to represent S. And then obviously from here, hopefully you can recognize that that's going to be 3 as well. So the perimeter is going to be S plus 3 plus 3 plus 6. Right? So again, what does S equal? Well, S equals R, but that's in radians. So therefore, we're going to take 113 degrees times pi over 180 degrees. Okay? And then we're going to multiply it times the radius, which actually we don't know. Oh, we do know the radius, which is 3.6. So that's going to give you S, and then plus 3 plus 3 plus 6. Okay. All right. Now the next one is going to be finding the area, and I don't really have time to go through everything in terms of this. And I believe that would work for that area of the sector. Believe it on that regard. The next one is going to be finding the area. And the main thing I just wanted you to again see is if you want to find the area, you can find the area of this box, right? And then what I'm assuming you need to also be able to figure out is be able to figure out the area of the triangle or an area of this sector piece right there. And to be honest with you, it's actually been a while since I've gone through all those. So based on not knowing what you should know in your certain class, there's a couple different ways you can do that. You can find the area of the sector. So the area of, what is it? Trying to find you're trying to see if it equals 24 meters squared. So a couple things that I could do is you could find the area of the rectangle, right? So find the area of the rectangle, 6 times 3. You can find the area of the sector, which you have all the information you need for the area of the sector. And then you could also find the area of the triangle. So let's actually do this. So if I want to find the area of this shape, one way you could do this is, let's say the area of the shape, or let's say the area of the tunnel. Okay. If you want to find the area of the tunnel, what you could do is you could take the, let's see, find the, so find the area of the sector plus the area of the rectangle. And then you can see what they share is going to be the, you can see that they share this triangle. So then subtract the area of the triangle. Okay. And to find the area of the triangle, you would need to be able to figure out what this height is. So just make sure you go ahead and figure that out. All right, but hopefully that kind of at least gets you on the right path to be able to solve that. And now we bring it into our first little open question for on there. And therefore I would see, and I see Cody, how do you solve a multi-step inverse equation? Ugh, what is that? I don't even know what that is. Just need to show me how to do this specific question. TikToks, hola. And Seminus, thank you so much. You are very welcome. Providence Gaming, well, hello. Canslam, hola. And looks like, man, yeah, that's a lot of the sometimes, Addy, that sometimes comes up. And Morgan, well, thank you so much for all those. It's been a while since I've been covering my arithmetic and geometric sequences. That's why a lot of times I don't cover them in my live streams, just because it's been such a long time since I worked through those kind of problems. So, and we'll go from, so a lot of times I gotta, one of my things that I found out from my post that I had from you guys, I'm like, holy crap, I need to brush up on a lot of my, definitely on my math kind of stuff, working through some, some more of these problems, because you guys, there's such a wide variety of questions that have come up. Multi-step inverse equations. I don't find inverse of x. I don't know. Oh, that's the 1/3. Here. I think I got yours, Cody. I'm assuming, Cody, you did post it in there, so maybe I'll try to find the range. Nobody wants to find the range. No problem. The domain. Trying to get the range of fx. No problem. The domain. Okay. Well, yeah. So the range, you could find the inverse typically of that, or you can look at that. You might want to simplify x minus 2 from there. Greg, I actually do have an SAT playlist. It's actually something I haven't done in a very, very long time. But if you actually look at it, actually what I can do is I can go and look for you on my SAT playlist. And what I'll do is I'll put that link. I'll probably do it in the post, but I do have some ACT, SAT questions. It's not a lot because obviously I haven't spent a lot of time doing that of SAT, ACT prep. But I do have a playlist on that. So find f inverse of x. So there's another question that we're going to do the inverse. So we might as well just kind of go through that first. So let's go through the process of identifying the inverse. All right. So here's an open question for you, Cody. All right. So first thing, we want to swap the y, or replace f of x in y notation. You don't have to do this, but it just makes life a little bit easier. The next step is understanding the relationship between a function and its inverse. They are going to be reflected about the y equals x line. And basically, if you remember from geometry, which I also recently taught, the x and the y coordinates are swapped when you are reflecting about that y equals x line. So algebraically, we're going to swap those lines as well. That needs to be a y. And then once you swap them, you're just going to use your inverse operations to solve for y. Now, we do want to look for constraints if we do have that ability, because we want to make sure our function is going to be 1-to-1. And the cubic function does pass the horizontal line test, so it is 1-to-1. So we don't need to worry about any restrictions. So I will add a 6 here. So I have an x plus 6 equals 5. That's going to be times the cube root of y. Divide by 5, divide by 5. I'll just write that as 1/5 x plus 6. Just makes things a little bit easier. And then we'll have the cube root of y. And then to undo the cube root of y, I will cube both sides. And therefore, I'm left with 1/5 times x plus 6 cubed equals y. And again, remember that's the inverse, right? So we want to use this in inverse notation. So f inverse of x is going to equal 1/5 times x plus 6 raised to the third power. And again, there's multiple different ways you could write this. You could also write it like this, like x plus 6 over 5 cubed. That's also an acceptable form as well. All right, guys, I will get to more of your questions. I actually had 2 open for the rest of them. I'm not really sure why I did this from on there. But I had another sector question, and I haven't covered sector questions in like forever. So I was kind of happy. I was kind of surprised that I decided to work on these. And I apologize if I'm making maybe even a mistake. It's been a really, really long time. Over 10 years, actually, since I did any problems with sectors. So been a while. I guess maybe I probably did some in calculus. I just don't remember. But all right, so it says 2 sectors are cut from an isosceles triangle as shown. Find in terms of pi the area of the remaining shape. Well, I think what I liked about this is I had the area of the sector from the previous one, right? Because I'm like, I don't remember that formula. So it's going to be 1/2 r squared. What was that, times theta? Yeah, times theta, okay. But again, that is when r is in radians. So we're going to need to convert that, okay? So that is going to be the sector. So actually, let me do this. Okay. And if I was going to convert that, so I'm assuming if you have these 2 sectors, so this is a 45-45. So this is important for us to recognize. If this is a 45-45 90 triangle, all right, that is going to be an isosceles. That means these 2 triangles are going to, actually, sorry, we don't know that. We know that this is we know this is an isosceles triangle. Now, if I create a perpendicular bisector or angle bisector right here, okay, what that's going to produce is a 45-45 90 triangle. Now that's very important because if this is a bisector, then I can create this to be 40 and this to be 40. All right. Therefore, using my relationship of 45-45 90 triangles, this is going to be a height of 40, and this is going to be 40 times the square root of 2. That is based on my relationships of special right triangles. So that's important because I need to be able to find the area of the triangle. So the area of the triangle is going to be 1/2 base, which is going to be 80 times the height. So that would be 40 and that would be 4. So that would be 80 times 40. Okay. So then it's asking us to multiply our 2 sectors. Well, we have 2 of them, right? So we have 2 times the area. And so let's just do 2 times 1/2. Now we have our r, which is going to be from here to here, which would be 40 squared. And then that's going to be times theta, which again, that is in radians. So if I have my angle, which is 45 degrees, to convert that to radians, then I'm going to take 45 and multiply by pi over 180. So that's going to be, a 45 pi over 180 degrees. So that'd be times a 45 pi over 180 degrees. Whew. Okay, so that's going to be your area of your 2 sectors. Actually, let's just there. Okay, and area of your 2 triangles is b from there. So actually, let me just simplify this out. Let me put this over here. There you go. And then this, I'll just bring this down. I'm not going to calculate this because I have way too many questions I need to go through. So, but hopefully that helps you at least get set up. 1/2 base times height. All right, the next one is a trigonometric identity, 2 tangent of x minus 1 plus tangent of x quantity squared. So let's go ahead and expand this. So we have 2 tangent of x minus, if we expand that out, there will be 1 plus 2 tangent of x plus tangent squared of x. Okay, and notice that we're outside these parentheses. So if we apply good old distributive property here, I'll get a 2 tangent of x minus 1 minus 2 tangent of x minus tangent squared of x. Okay, well, those are now going to subtract out. So you're left with 1 minus a negative tangent squared of x. And again, whenever I'm looking at a trigonometric function squared, I'm trying to simplify or verify the identity, I'm going to think of my Pythagorean relationships. But this is not a Pythagorean relationship. But if I factor out a negative, it is. And that is going to be secant. So therefore, this is negative secant squared of x. All right, the next one was question number 7. And this one was evaluating our trigonometric functions or the composition of our inverse trigonometric functions. And fortunately, they gave us 2 angles that are not on the unit circle. Love it. So it's important to understand when we're using the inverse of our trigonometric functions that we have our restrictions aligned. And remember, the other thing too is that if we don't know the value, like, or the angle, or if we have this inverse here, we can always remember, we can always recognize this, as a triangle. I'll get to it when I get to there. So on the first thing, let's just kind of understand what is negative 35 pi over 9. All right, let's just understand this question. So if I was going to graph that, I guess like this. Okay. If I was going to graph this, I know that's going to be going around, let's see, 9, 18, 27, 36 would be all the way around, right? 2 times all the way around. But we're at the negative 35. So you could say, oh, okay, so it's going to be somewhere around there. So what is this reference angle, right? How far are we away? Well, theta prime then is going to equal pi over 9, which is actually the answer. The reason why that's the answer is because if you're going to find the inverse of this function, it has to be an angle that satisfies the restriction of sine inverse, which means it has to be between negative pi halves and pi halves. Well, obviously, negative 35 pi over 9 does not satisfy that restriction. It keeps on going outside. It's way over it, right? It has to be between negative pi halves and pi halves. So we know that these angles, the reference angle is going to be the same. It's going to be coterminal, right, with negative 35 pi over 9. But it's not only it's coterminal, but it satisfies the restriction. That is why that is going to be your answer. So basically what you get is you get a sine inverse of pi over 9. Well, that's already within our restriction, so that's just going to equal pi over 9. That's why that's the answer. Now on this one, I don't have the calculator, but I'm assuming that 19 squared plus 18 squared is going to be 685. Because basically all we're simply doing here is we don't know what that point is like on the unit circle or what angle produces that point. So we can always go back to creating a triangle, right? So let's just create a random triangle and say, okay, cotangent is 19 over 18, right? Based on an angle theta. So basically what we're saying is, well, what is the sine of theta? Well, that's going to be the opposite over, and I'm assuming this is 685, right? Using the Pythagorean theorem, 19 squared plus 18 squared equals the square root of 685. Assuming. Or equals 685. 9 squared plus 16 squared equals the square root of 685. And so therefore, it'd be 18 over square root of 685. And there you go. So that is what that would, yeah. So then that's the simplified version. Obviously, they just rationalize the denominator. All right, so now it brings us into another open question. So if you guys have any other questions any questions you guys would like me to cover on this, answer, I think my chat is around the below. So let's get back into it. Say hello to some of you like Crazy and Programmer. Morgan, Simplify Expressions. If you guys can give me a little bit more detailed ice of water. Well, thank you very much for summing at that. Thank you for your church into quarantine. You are very welcome. Angeline, how do you solve inverse functions, table and graph? Just remember, I mean, it's the same thing as the quadratic. Just remember that just remember that you're just swapping those coordinate points, right? Oh boy, I might have been a little bit crazy by going through the questions for you guys. Ryan, I'm not going to be able to solve the Riemann hypothesis. I don't have enough time to go over this, but if you keep on asking multiple times, that is the fastest way to not get your question answered. So I do apologize for that. I just don't have time to go over so many different questions from on there. But how to add 3 questions of parallelogram method. I don't know, Raymond. I don't recall the parallelogram method for the 3 vectors, so unfortunately I won't be able to cover from there. Any other good websites to practice math problems? No, I don't. I'm not really as much sure for you on that. As far as, I mean, there's a lot of, I think really Google and YouTube could be your friend as far as just finding some different websites that, help out. Obviously, Khan Academy is great. They have a lot of examples. I think anything where you can find the answers or have the answers provided to you is going to be very beneficial. Well, hey, Abraham, can you involve quadratic equation? Sure, Kessler. I see your question, so I'll go ahead and add it into there. How about graphing secant? Nobody wants to do those. Can you question on adding and subtracting negative numbers and fractions, please? Cam Slam, I saw you added that before, so I'll get to that. Can you do a quick lesson on adding and subtracting negative numbers? Yeah, you know what? I'll just gonna do this quadratic equation. And actually, I made a video that's gonna be coming out, and then add, subtract, negative. I'm just gonna do negative fractions. Okay, just to kind of keep, because I don't know what else to kind of go in from there. So the main thing is, you know, I think when you're doing the quadratic equations, I think it's very important for you guys to know how to graph, to make sure you guys know how to graph your two equations. Or I'm sorry, graph, what am I talking about? That is very important, I think, you guys to go ahead and factor everything, be able to solve your quadratic equation. That's going to make your life so much better by being able to quickly solve any quadratic like that. However, sometimes you're going to have a quadratic that's going to be very difficult to factor, or it's not going to be some nice number that's non-factorable across your rational powers. So in that case, what you're simply going to need to do is make sure you can follow the quadratic formula. You can always go ahead and look into using, completing the square. But, for instance, if you just had 2.1 x squared minus, let's just go through. Let's just make up a random equation. Something easily I can do. 2x squared minus 3x plus 7 equals 0. So it's very important to make sure when you're doing the quadratic formula that you have everything in standard form, ax squared plus bx plus c equal to 0. Okay. So a lot of the problems that we see in here is we have them in our standard form set equal to 0, or they're not in standard form set equal to 0. So make sure you put them in standard form, set them equal to 0, and then just be able to identify your A, identify your B, and identify your C, right? So it doesn't really matter if you're dealing with decimals or fractions, or if you're dealing with really large numbers. Just, make sure it's in standard form equal to 0. Make sure you identify your A, B, and C. And then in this case, all you're simply going to do is just plug it in. Opposite of B, plus or minus, square root of b squared minus 4 times a times c, all over 2 times a. And then from there, it's just really a plug and chug and making sure that you simplify things. Remember that the opposite of b, opposite b doesn't mean negative b, it just means the opposite sign. So that's going to be 3 plus or minus negative 3 squared minus 4 times a, which is 2, times c, which is 7, all over 2 times a. Okay, and now I completely made up this problem, so I'm not sure how these numbers work. So this is going to be 9 minus, let's see, that's going to be 4 times 2, which is 8. So that's going to be a negative 56, right? So 9 minus 56 all over 4. And then in this case, that's going to be 3 plus or minus. That's going to be 9 minus 56. That'd be a square root of a negative 47 divided by 4. And from that case, you could obviously rewrite that using our imaginary numbers over 4. Okay, so, and again, obviously you can simplify the radicals, and there's a whole bunch of things, but you just wanted to ask for a quadratic equation. So there's something on the quadratic equation. And again, guys, I only have a couple of slots for these questions. So a lot of times I'll just get into these things. I'll just make a quick little, stop for you and say hello, and then from there we'll just make sure that I'll answer some of your questions. But again, guys, most of these questions that I'm going to be answering are going to be put into the that have been pre-submitted. So you don't need to go into so much on the chat. I'm posting your questions because I'm not going to be able to. I'm just taking a couple breaks throughout the live stream to be able to check in on some of the questions that I see. So you don't need to keep on repeating it every single time for me. So just for the sake of everybody else that's putting in there. So open, add a, subtract a negative. So add and subtract negative numbers. Okay. So I think it's very difficult for a lot of students to understand the idea of subtracting and negative. So a lot of times what I would just recommend is if you have something like, negative 1/4, plus, or let's just do it like this. Minus 2/3, right? So we'll do that example. Let's just do this example, So it said add and subtract negative fractions. We'll just keep it from there. So the main thing that I would like to do whenever I'm subtracting is one thing you can always do is rewrite this as an addition problem. So I can write this as negative 1/4 minus a negative 2/3. Sorry, plus a negative 2/3. Don't do that. You got to rewrite it as an addition problem. So it's negative 1/4 plus a negative 2/3. Okay. So now it's kind of like you owe me, so if I said like something, you owe me $5, right? And then you also owe me like $7, right? Like you can just combine like you owed me $5 on Saturday and then you owed me $7 on Sunday. Like how much money do you owe me? Well, that equals a negative 12. Right? So I think it's easier to understand addition because it's that combination, and just think of like negative as like owning. And that's the way that I remember or make sense of negatives. And that's just what's always connected from me, is understanding the idea of negatives as being like owing, money in that case. All right, so now what we need to do when we're doing fractions, though, we got to make sure we have a common denominator. So you can only subtract fractions when they are divided by when the denominators are the same. So in this case, what we need to do is identify, well, what is the smallest number that 4 and 3 divide into that they would have in common? So you can list their multiples of 4 and 3, and hopefully it doesn't take too long before you identify that the least common multiple of 3 and 4, or least common denominator, is 12. So then all we're simply going to do is say, well, what number do I need to multiply by 4 to get it to be 12? Well, that'd be 3, right? And then plus, now here's where sometimes students get tricked up. Like, should I put the negative up top or on the bottom? Well, when you are doing with fractions, remember, we want to keep the denominators to be the same, and we're going to apply the operations to the numerator. So typically, it's just going to be easiest to put the numerator, or you're going to put the negative in the numerator. And then what two numbers should I multiply by 3 to get to 12? Well, that's going to be a 4 over 4. So this gives me a negative 3/12 plus a negative 8/12. And when you add them up together, you get a negative 11/12. So there you go. Hopefully that was helpful out. All right, this one is from Strongy. It says, I do not understand the limit notation, expressing the limits. For example, what are the small plus and minus signs? It took me a second to remember. I'm like, what is he talking about? So then I was like, oh, now I get it. All right, so if we're looking at a graph, and let's just look at -1. So let's just look at here, and then let's do 1, 2, 3. Actually, let's do something like this. Oh yeah, it doesn't matter. Okay. Then 1, 2. Okay, so here's that limit -1, and let's call this function f of x. Okay, so there's 3 different functions that we can talk about at -1. We can talk about the limit as x approaches -1 from the left. Okay, so that negative basically means like your left-hand notation. So this is obviously my left hand. As you guys are looking at this, it's going to look a little bit weird. Look to my right, right? But this is your left hand. It's basically saying, where is this graph approaching from the left? So as you read the graph, right, from right to left, or from left to right, I'm sorry, it's like what y value, what output value is the graph approaching? So as we're reading this, you can see from left to right, you can see the graph is approaching -3. So the limit as x approaches -1 of this function f of x, that's going to equal -3. Now the limit as x approaches -1 from the right is basically asking, well, where is this graph approaching from the right-hand side? So now we're not reading the graph from left to right. We're going to read the graph from right to left. So you can think of like this as like a ramp. Like as you're riding along on this graph, you say you're going to the left. Like what are you approaching? What is your output, your y value that you are approaching of this function f of x? And you can see that's going to be the value 2, right? As you're getting over here. And again, here you have an open hole, right? So it's actually never going to equal 2, but that's what it's approaching. Where in comparison here, it actually can equal -3. So that's why it'd be equal. So therefore that one's going to be 2. And then last but not least is what we call the general limit. And the general limit is just going to be, without those little negatives or plus. And that's saying, where is the graph approaching from -1 from the left and the right, right? And it has to be approaching the same value from the left and from the right. And since at -1, we're approaching -3 from the left and 2 from the right, we're not approaching the same number. So this one does not exist. All right. Is there a concept or process you're having trouble with that can converting logarithms exponential? So when you have to convert, thank you, Patrick. When you have to convert exponential to logarithmic, the best way that I like to do it is just think of a exponential equation, like 2x to the 8th, right? Or sorry, 2x to the 8th, 2 cubed to the 8th. Like, okay, that is in exponential form, right? Okay, so remember a logarithm is basically going to be the base is the same. So that'd be a base 2. And it's basically saying 2, like 2 is your base, right, of your exponent. So 2 raised to what value gives you 8 is going to equal 3. So when you're looking at a logarithm, that's basically how we can understand and interpret that logarithm. The base is always going to be the same. Okay, and this is the logs. All right, so then the power is what you're equal to, and then the argument here is 8 is what it's going to be equal to in the exponential equation. So a lot of times students will just, when they're first getting used to this, they just kind of remember how those kind of relate to each other. Whenever I kind of get confused, I always just kind of think about this as like, this is my base, like 2 raised to what value gives me, gives me 8, right? And that obviously your answer is going to be 3. So you can just, I think just remembering the bases are the same. And then from there, and hopefully, in the exponential, that makes sense, right? 2 multiplied by itself 3 times gives you 8. And then you can just convert that to your logarithmic. Jim asked a question to solve. He didn't say on what rate. So sorry about that, Jim. But we'll try to go through there. Minus 3 sine of theta plus 1 equals 0. Okay, so the first thing I recognize in this is it needs to be factored. So if I had a 2x squared minus 3x plus 1 equals 0, I know I could factor that into a, let's say, a 2x. X, what two numbers multiply give me 1? So that'd be a -1, and that'd be a -1, right? Yep, that looks good. So therefore, I can rewrite this. Then instead of x, I can use sine. So this would be a 2 sine of x, not x, theta. 2 sine of theta minus 1 times a sine of theta minus 1. Okay, so now we can just set these both equal to 0. So I could say a sine of theta equals 1/2 and sine of theta equals +1. Now I'm just going to solve this on 0 to 2 pi. Okay, so when does sine of theta equal to 1/2? Well, it's going to equal 1/2. That's going to be at pi over 6 and 5 pi over 6. And sine of theta is equal to 1/2 at pi halves. There you go. All right. Well, hello, Arcade Master and Logic and Garlic and First Name and 1778 Tony. Thank you so much. Danielle, write a polynomial function of a volume of a box with the given dimensions. What is the width of the box? No. Well, Frank, thank you, Freddie. I appreciate that. So as far as the length of the, what is it? Write the polynomial function of the volume of a box with the given dimensions. What is the width of the box if the volume is 120? I don't know. I'm not sure if I have enough information for you on that. You are very welcome. You are very, jeez. Brian, is it just, what's my skin? Stanley, I saw that before, my skincare rotation. I'm going to have to give all the credit to the camera for me on that, because that is definitely not something, which actually I might as well give a plug on to let you guys know. So, as far as on the questions that a lot of you guys have been getting into me, Bernadette, yes, I will answer one of your questions, and actually have another open, don't I? Yeah. But thank you, Bernadette. I'll actually give them that one. Seems horrible though, or not horrible, but not something I want to do. Maybe I'll just get you set up. That's a negative. Jeez. All right, I'll probably at least get you set up for there. We'll maybe look into factoring this. We'll see. So that's going to be solve. But also I want to let you guys know, like a lot of these questions, coming through, really fast. I want to let you know also, if you do have a lot of questions or you do need help, I do also do a bonus live stream in my YouTube membership each and every month. And I'm actually doing 2 bonus live streams for them as far as my, I'm also doing 2 bonus live streams for the semester exam. So when I go live on my December 5th in my pre-calculus course, which for those of you taking pre-calculus, if you guys want to look into that, see if that's the right fit for you for pre-calculus, that is also something that my members are going to get access to, at least just the live stream. They're not going to get access to the course materials and everything I have there. But so if a lot of times students are, wanting to know, they want a little bit more personalized attention as far as their questions go. That is something that I do offer as far as answering your guys' questions before they're on that. And Sweeney, I see yours. I haven't covered anything on the focus, so congratulations. I will do that one next. And I do apologize for the rest of you guys. And, Yoko, the weirdo, PA shout out, sure, whatever. But I do want to give you guys a -2 times x plus 4. I can't remember what I was going to say. I don't know. Oh, I just have some more questions. Cream says, what is your favorite cereal? I actually do not have a favorite cereal. I actually don't like cereal. I've never really liked cereal. I don't really like milk, so I never really drank milk. That's actually one of the few things I really like to enjoy, eat and drink everything. I just do not like milk, and so cereal has never really been my favorite. I will say maybe, though, if I did have a favorite, maybe Cocoa Puffs was always like my favorite one to always have. Cocoa Puffs and Lucky Charms. I think those are kind of like my two favorite. I really did like Pops. Pops was always actually really good. And Raisin Bran. I did like Raisin Bran a lot when I used to have that. I remember having a lot of Raisin Bran. So yeah, those are some of my favorites that I used to have. And Aaliyah says, why algebra is so hard? Because yeah, definitely it is so hard because it is very abstract, you know? So, I mean, you got to have a lot of these connections and relationships and to better understand what we're trying to do in algebra. And sometimes it just takes a little while for your brain to kind of make those connections, and that's perfectly fine. So there's nothing wrong with you if it feels really, difficult and something that you cannot understand, because that's definitely not the case, but it is something that you develop and you learn through. And to be honest, not everybody, develops those skills and that preparation at the same time. So don't feel rushed for on that. And Steve, I do not do any tutoring for the SAT, so I do apologize, but and also I just don't have time, like literally don't have any time to do any private tutoring. All right, so let's go ahead and get it through these questions. So I like this question. The reason why I brought this one up, Bernadette, is because this is like one of the questions I saw like for quadratic formula. Like quadratic formula is fairly basic, like once you kind of get the idea of it, but typically you're not going to get a quadratic equation like just in quadratic standard form. You're going to get something that's going to look like this. So what we first need to do is simplify this. So I'll multiply this out. Distributive property. So let's see, that's going to be 4r squared. That'd be a negative 2r, 6r. So that'd be a positive 5r. And then minus 3 equals distributive property here, negative 3r minus 1. So then we need to add a 3r, then add a 1. All right, so let's see if I can figure out if this is factorable. Minus 2 equals 0. You could factor out a 2. So it'd be r squared plus 6r minus 1. And I am not seeing that to be factorable. So I would divide out oops, that's a 2, right? Yeah, so not seeing how that's going to be factorable. So I would divide out 2. And please let me know if I do make a mistake, guys, from on there. All right, but I'm not seeing anything I made. So therefore, you would want to use 2r squared plus 6r minus 1 equals 0. You're going to want to use the quadratic formula. So I did that in the previous problem, so I would go ahead and check that out. It doesn't matter if it's x's or r's, but you'd want to go ahead and solve that using the quadratic formula. So the main thing, guys, is when you're trying to solve a quadratic, set the quadratic equal to 0. Okay, that was your main thing I want you to kind of take away from this. All right, so the next one is finding the focus. So the first thing we need to find the focus is we need to understand the opening of the graph. So since y is squared, that's just kind of like a regular parabola. No, it's gonna be open left or right, right? So if x is squared, it opens up or down, like that's like a quadratic equation. But when y is squared, it's gonna be opening left or right. So then the next thing we need to do is understand, well, what is our p? Is that gonna be positive or negative? And since our p is going to be negative, it's gonna be opening up to the left. So that's a negative p, that'd be a positive p. So this is gonna open up to the left. The vertex is going to be h comma k. So actually, let me show you this. So let's go through the standard form. So this is y minus k, y squared equals 4p times x minus h. Okay, so the vertex is hk. So that's going to be a negative 4, negative 4. And then my p is the distance from the vertex to the focus, right? So to find that, I have negative 2 equals 4p. So divide by 4, p equals a negative 1/2. And again, that's going to be, since it's going to the left, actually don't really even need to go through this, but we just know it's going left or right, right, since the y is squared. So to find my focus, I'm just going to take negative 4 plus you're going to add your p to get your focus negative 1/2 minus 4. Okay, so let's go ahead and add these together. So how do you add an integer to a fraction? Well, what you can do is you can convert your negative 4 to 1 minus 1/2. Get the common denominators. So you can rewrite, multiply by 2 over 2. So this would be equal to negative 8 halves minus 1/2. So it's going to be negative 7 halves. No, I'm sorry, negative 9 halves. You owe me $8, you borrow one more dollar, right? So that's going to be a negative 9 halves, comma, negative 4. So hopefully I didn't make any mistakes from on there. Any chance you could look at this problem? Doug, that's a lot of factoring, Doug, but you only need to write it once, and I don't have any open Q&A for at this moment, so just hold on a second till I get to my next round. The next one says, solve the equation, check your answer. So basically, these are just going to be inverse operations. So we're going to undo. I'm not going to check the answer. I'll tell you what to do. But for the sake of time, since I'm only halfway through my lesson, oh my God, I am not going to be able to go through checking the answers. So this one says, solve the equation, check your answer. So again, what we're trying to do is just undo what's happening to the x. So you're going to subtract the 8. Because you always want to undo addition and subtraction first. So 5x, that's going to equal a 15. And then you undo multiplication by dividing. So x equals 3. And then if you want to check your answer, you just plug your 3 back in for x to make sure it satisfies the equation. Because if it is a solution, it's going to make the left side equal to the right side. And again, you can see that this case, it works. 23 is equal to 23. Okay. Now, when you had something like this, it's the same thing. You're always undoing addition and subtraction first, right? So that's going to be 6. And then now you just undo a negative 2. So p equals a negative 3. And then you can go and plug it in. And this one would be the exact same process. Here, this question number 16, you can just use the rules of logarithms. Like if you have ln of e to the x, that just equals x, right? That is one of the rules of logarithms because ln is base e, okay? So the nice thing about this is just going to give me ln of 3.6 is equal to 0.031x. Well, now we can just use our inverse operations like we did up here and then just divide by 0.031. So x, you're going to want a calculator for this, is ln, not ln, ln of 3.6 divided by 0.031. There you go. Althea says, find the domain and range of f inverse of x. So we talked about the inverse function. And you remember the inverse function is a reflection about the y equals x line. So, and also these points are just being reflected from one another. So I'm assuming this point is 2, 4. So therefore my f inverse function is going to be 4, 2. Okay. So when we're looking at the domain and range from a graph, we can basically say how far to the left is the graph going, how far to the right is the graph going for the domain. And so the domain is going to be, looks like it's going from 0, which it looks like it's defined. So that's going to be a closed bracket, and then all the way to infinity. And my range looks like it goes, the lowest it goes is going to be 0. And then the highest it goes is going to be infinity, right? Because that's going to be the range, how low and high does the graph go. Achilles says, using the characteristics f of x is negative x squared plus 7x to sketch it, and it's reciprocal on the same set of x's. I'm not sure what you mean by the reciprocal. Can you tell the arithmetic sequence? No, I'm not covering much of arithmetic and geometric sequences for you, so you can keep on typing it, but I'm probably not going to get to that. All right, yeah, I'll help you with graphing this one to sketch it. I'm not really sure what you mean by the reciprocal function of that. Like 1 over x of that. I don't know, let's see if we can graph that, and then I guess I can make sense of it. Yeah, we'll have to go and see. And then, do you have any questions regarding slope or systems of equations? Does anyone have any questions? Okay, thank you for helping out. Michael. Let's see. Well, hey, Justin, and do you know how to do related rates? Yes, I do, but we're not going to be able to cover any related rates we're not going to be able to cover any of these questions in this. We do not have that much time. Can you please explain simplified expressions with polynomials? I would just need a little bit more help for a sketch as reciprocal, the same set of axes, I guess. Yeah, I can kind of cover that a little bit. The reciprocal, I guess. We'll go ahead and take a look. And, whoa, no word problems, guys. Word problems, we don't have time for word problems. Clay says, find the discriminant of the quadratic form and describe the number of solutions. Okay, I like that one. So I'm just going to cover that one because that's simple and I can see the equation. 5x squared minus 4x plus 2. And I do apologize for you guys. I know I can see you coming through chat. I wanted to take a couple breaks, but please understand, guys, I have 32 questions that we're trying to get to tonight. And typically this is where I end off my streams. So I'm not going to be able to do any of these more elaborate type of questions, but I am going to go over my time limit because, I post you guys in the community post, what do you guys need help with? And I was overwhelmed with the number of types of topics that you guys need help with. So I know this is something that you guys are looking for. So I'll try to make sure that I do have a couple more stops here that I will make sure I stop my instruction and then just kind of see what I can help you guys out with. But if it's not something I can quickly and easily recognize your question and be able to give you a response, then unfortunately it's just not something I'm going to be able to cover. And I am not a math genius. Trust me, I am not a math genius. There's a lot of math that I have not done in a while, have never done, or just don't remember or just need to brush up on. So relected equation. Yes, Victor, I can help you with that, or maybe might be able to help you out with that, but just wait till my next open break, which I think I have a couple more, only a couple more. All right. So, and just remember, guys, if I'm not getting to your questions, I'm not trying to be rude, but I did have 60 questions, I think, that were submitted to me today. So you can always go ahead and use your Google form that is in this description. And also I have an exam review that you guys can also check out in the description as well. For you guys, if you are preparing for your exam and you're like, I have a ton of questions, I need help. Well, I'm not going to be able to answer all of your questions for you, but I do have an exam review that hopefully can help you out. And then if you're in pre-calculus, I do have a way for me to answer a lot more of your questions and also give you more private tutoring. But that is something that is a little bit more of a premium side. All right, so I can't even remember what this question. Oh, it's like graph it and then graph the reciprocal. All right, so if you're going to graph this, the main thing I think the main thing that I'd want to do here is actually just find my x-intercepts. So if I just want to find the x-intercepts here, okay, what I would do is I would set y equals 0, and I'd say negative x squared plus 7x plus 6, because it's just sketch. So I'm not going to find the vertex form. And what you can do is you can factor out a negative. So this would be a negative x squared minus 7x plus 6, right? All right, so I can factor out a negative 1. So then I get a 0 equals x squared minus 7x plus 6. I can factor that down into an x minus 6 times an x minus 1, okay? So therefore my x-intercepts are going to be x equals 1 and x equals 6. And then also I know that my a is a negative, so therefore the graph is going to be opening down. Okay. So I'm going to go to 1 and then 1, 2, 3, 4, 5, 6. Okay, so I don't know where the graph is going to have this vertex, but it's going to open up somewhere down there. Now, the only difference is I believe what the student was asking for g of x. I don't have time to go through all this, but I can give you the most important details you want. Let's go maybe do a blue or something. So let's actually do this like that. I can't believe I've actually never done a blue here. All right, so if I gave you this one, like I believe this is what you mean by the reciprocal function, because I believe then the main thing is you want to do is the values that are going to make the 0 are now going to turn into your asymptotes, okay? And then typically what I tell my students to do is you can also identify the horizontal asymptote, which is going to be at 0. And then to know the behavior of the graph, there's going to be no y-intercepts. So you would just find the x-intercepts, the y-intercepts, and then also be able to identify the coordinate points. So I typically like to pick 2 points to the left and to the right of your asymptotes, and then you can go ahead and sketch it from there. So hopefully that at least gets you kind of started in the right domain. The next one is the discriminant, which I think is pretty important, especially for those of you that were doing the quadratic formula, to understand if you're going to be dealing with irrational solutions, real rational solutions, or complex solutions. So remember the quadratic formula, which I did previously in my stream, opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So the discriminant is equal to b squared minus 4 times a times c. So find the discriminant, or evaluate, and then label the solutions, right? So the reason why this is so important is because this is what you're taking the square root of. So if this is a square number, that means you're going to be able to take the square root of it and you'll have one solution, right? That means it's going to be a real rational solution, with one x-intercept. If you cannot take the square root of it, then you're going to have two irrational solutions. And if this is less than 0, but it's negative, if it's less than 0, then you're going to have a complex solution, meaning it's going to be an imaginary solution. It's not going to actually give me an x-intercept. So what we're going to do is we're just going to plug our values in. So negative 4x squared, or negative 4 squared, minus 4 times 5 times b. So that equals 16, and then I can automatically see that this is going to be two complex solutions. That'd be minus 40. So that equals a negative 36. Okay, so since that's a negative, that would be two complex solutions, or two complex roots, whatever may be the case. All right, the next one is find the angle 0 between 0 and 360, or 0 and 2 pi radians. That is coterminal with the given angle. So, I don't know why these angles, these are kind of tricky, just with the angles. But again, like, you can rewrite this as a decimal, right? You can say this is negative 28 degrees plus 48 over 60 plus 65 over 3600. But it doesn't really matter like what the decimal version of this is, I guess, because all you need to do is you just need to add 360 to it. And I guess maybe the student was confused of like, how do you add, how do you find coterminal angles, that's within this restriction? I guess that can be confusing because coterminal angles are just angles that have the same initial and terminal side. So you could go all the way around. So basically all you're doing is adding and subtracting 360 degrees, or adding and subtracting 2 pi, right? So you can go in the positive direction, you can go in the negative direction, and you can keep on going around in any really direction that you need. So if I already have a negative angle that's less than a 2 pi, you just add 360 and that will take you into this restriction. Now I guess here you can see that, well, how am I going to subtract here? Like, what would this be? So again, let's think about this. Well, 2 pi is roughly 6.28, right? Approximately. So if I took 10 minus 6.28, let's just do 10 minus 2 pi, right? Because you wouldn't want to add 2 pi if you're trying to get between 0 and 2 pi. So if I did 10 minus 2 pi, 6.28, roughly, right? You're roughly going to be dealing with that's approximately 3.72, right there. So therefore, you'd want to subtract 2 pi one more times. So just as an approximation, I would say 10 minus 4 pi. And again, you have to do it in terms of 2 pi's, right? Because that's a whole revolution. So you wouldn't want to do 2 pi once, because then that would give you a radian of 3.72. And they said they wanted, oh, actually, never mind. That would give it to you. I'm an idiot, because 0 and 6.25. Yeah, so you just want to subtract 2 pi. Never mind, I take that back. So that equals 6.2 pi is 0.28. So yeah, that would satisfy. That would work. All right, my brain is starting to go, ladies and gentlemen. I'm on question 21. So this student was asking about the point slope form. Where is it derived? Because most students are like, okay, yeah, mx plus b. I like that form, right? Like, okay, good. What about point slope form? Well, point slope form is very helpful, especially when we're given points on a graph and we need to write the equation of the line. So remember, the slope of a point is the change in the y coordinates over the change of the x coordinates between any 2 points, right? And we can call these 2 points x1, y1 and x2, y2. Well, if you just multiply by x2 minus x1 on the left and the right hand side, then you're going to get the equation of a line in what we call point slope form. Now, typically we just kind of rearrange this, And we don't really use 2 points. We kind of just drop the second point because typically when we're talking about point slope form, we're talking about a point, not 2 points, and the slope. So we kind of drop this 2 and just say y minus y1 equals m times x minus x1. And there you go. The next one is there a specific problem you'd like for me to explain on, so this student wanted me to do it in standard form. So now we need to go ahead and complete the square. Let's see, this is a hyperbola, I believe. Yep, hyperbola. So when you're doing a problem like this, you want to group the x's together. So we get a 9x squared plus 90x plus 189x minus a 4y squared equals 0. Okay, so you can't really do anything with the y as far as completing the square. That's not a 199x. Sorry about that. So you can't really do anything with the y as far as completing the square. So you're just going to leave it right there. And then we'll subtract the 189 to the other side. All right, now what we're going to do is factor out the 9. X squared plus, say, 10x squared equals 189. All right, and now we're going to complete the square. So take 10 divided by 2, which is 5. 5 squared is 25. So 9 times x squared plus 10x plus 25. We're going to add a 25 to the other side. But again, that's a negative. No, right. Yeah, that's a negative. So that's not a negative one. That's a negative 189 plus 25, but you didn't really add 25. You added a 25 that's being multiplied by 9. So 25 times 4 is 100. 25 times 8 is 200. So that'd be 225. Okay, so this can be factored down into an x plus 5 quantity squared minus a 4y squared equals 225, 189. I feel like I should know. That's going to be 15 and 13. That's going to be 225. Right? That'd be 225. No, that'd be 10. My brain. All right. You're breaking out my calculator. Now my brain's been hurting. So 9 times 25. 9 times 25. 225. Yeah, I had it right. And then minus 189. It should be 36. Ah, dang it. There you go. 36. And then all you're going to want to do to write this in standard form is you're going to want this to equal 1. So you divide by 36 on both sides. Like, eyes are getting watery. So 9 over 36 can be reduced to x plus 5 quantity squared over 4 minus 36 goes in the 4. So that'd be minus a y squared over 9 equals 1. And there, now you have it in standard form to go from there. Oh, all right. Well, hey, Sandeep and Arcade Master. Demon owns you. You are very welcome. Hello, Joanna and Useless Goddess and Samin and Earl, an unidentified user. Can you please do an exponential equation with a radical? I'm not sure what you would mean by that. So maybe if you can provide me an example, that'd be helpful. Well, hey, Matthew, this is actually so dope. Well, I'm glad I can be able to help you out. Maybe hopefully you're talking about my helping, being able to answer some questions for you guys. Yep. What times what is 49? What times what is 49? That'd be 7. 7 squared. So 7 times 7 is 49. Marcin, how do you do long division? Ooh, Ryan, you are asking a question that, well, it depends if you're talking about numbers or polynomials. I mean, it's the same algorithm, but kind of can go different ways for that. I have a pre-calculus test soon, so I have a question. Well, Rose, let's get that question in soon because I'm going to be picking some questions here from you guys. Just taking a little break. We're going to go a little bit longer on this live stream. I have 32 questions, so I got to get through these rather quickly, but we'll get to them soon enough. I think we'll almost. We'll see. Hopefully we'll be done here. All right, write the polynomial function, Daniela. I got one. I hate these questions. Just joking, Daniela. All right. But this one is, what is the polynomial function of the box? Oh, you found those dimensions. All right, cool. So we have 3x minus 4 times x plus 1, and then times x plus 3. Hey, NOK, thank you so much for your super chat. That is very, very nice of me. Or Emmeline, oh, that was in some currency that I am not aware. Nice that you're using your time to help out people. By the way, do you play chess? No, I do not take play chess. I just saw the NOK from the top. That's why I was like, so Emmeline, thank you so much for the super chat. I really do appreciate it. And I do play chess a little bit. Me and my wife were actually watching the Queen's Gambit. And so it was like, oh man, I remember this. But no, I don't play chess enough seriously to develop much of a strategy but in theirs. So, but nothing from on there. Please, these class 10. I don't know what class 10 would reference from on there. But thank you again so much for the super chat. And but yeah, I just play a little bit with friends from these. All right. Identify users. I'm not sure what the heck to do. All right. 7 times square root of 2. What was I trying to do? Oh, I got to read your question, Danielle. How do you find the standard equation of a circle using 3 points? Rose, I did tell you to pose my question. How do you find the standard form of equation using a circle with 3 points? I do not recall. Sorry. We don't cover that in our pre-calculus curriculum. And I feel like it's something that I do remember. I just don't remember on the right at this moment. So I do apologize from that. That'd have to be something I just have to look up and refresh my memory, but I don't remember off the top of my head. Where is it? Okay. What is the width of the box if the volume is 120 inches? So those are the side lengths. All right. Okay. All right. So the volume is equal to 120. Okay, so basically, I would just be doing this with so we know 120, the volume is equal to a 3x minus 4 times x plus 1 times x plus 3, right? So basically what you need to do is solve this, and then we are trying to look for what is the width of the box. So we're going to be solving for x. So first thing you're going to want to do is actually multiply this out. So you could do a 3x squared plus 3x minus 4x minus 4. That's going to be times an x plus 3. So 120 equals 3x squared minus x minus 4. And now you have now you can do distributive property again, or you could use the box method. And actually, you know what? I'm going to use the box method here. It just makes things a little bit cleaner and smoother. So I'll do x and 3, and then a 3x squared minus x minus 4. I'm not going to use distributive property. All right, so that's a 3x cubed. This is a negative x squared. That's a negative 4x. This is a 9x squared. This is a negative 3x. That's a negative 12. All right, so this gives me 120 equals a 3x cubed plus a 8x squared minus 7x minus 12. Okay, and then all you're simply going to do is set this equal to 0, and you're going to subtract the negative 120. So this is a 3x cubed plus 8x squared minus 7x, and this would be negative 132. Now what I would do is I would use my graphing calculator to be able to find the zeros or find the x-intercepts, the real x-intercepts. Those would be the solutions for your value of x. And then obviously your value of x, you're gonna possibly have one real solution and two negatives, hopefully. So therefore you just want to see which ones would make sense. So hopefully you only have one real solution, and then that's what you do. But you definitely want to use a calculator from there on that one. All right. Getting that, my chat is a little bit. Okay. HK Beats. Well, hey, HK Beats, how are you? Thank you for joining in. And Carlos, if my question is too long, it probably is because I have a little bit to go from there. 2ln minus 2 is writing as a single log. 2ln negative 2, right? Subtract your rows of logarithms. Find the hexagon. Many places in the Philippines are observing the community quarantine. Carlos, good to know. Let me pretend I can. All right. I'm not sure what you guys have been talking about, but that's perfectly fine. I'm not seeing any more questions. If the endpoints of a line segment is the line of symmetry, what happens to the coordinates of the image? I don't know. My brain is already hurting enough from there. Pelo, I don't have time to be able to go over proofs. I do have some plans, though, for covering some proofs on some certain questions from there. Can you go over operations with complex numbers? Yes, I can. I mean, let's just kind of go over it. Let's just do a simple one of these, like, if this is x plus I, let's do squared minus a 3i plus 1, right? So again, just treat like i's like x's, all right? So if you're going to square this, remember this is x plus I times x plus I, right? Minus 3i plus 1, okay? So here you can just get this x squared, and that's going to be xi plus ix plus I squared. So therefore, xi plus 2xi. Now again, remember I squared is going to be a negative 1, right? So that's going to be minus 1 minus 3i plus 1. And then from here, all we're simply going to do is just combine like terms, all right? And actually, the only like terms I have here is going to be my negative 1 and 1. So this is just kind of a weird problem that I decided, actually, why am I doing this? Why am I do this as a 5 or like a, yeah. Let's just do it as like 2 plus I. So this would be 2 squared plus 2i plus I2. So that'd be a 4 plus a 2i plus 2i is going to be a 4i. There you go. Then I can at least get some like terms. 4i minus 1. All right, so now I can combine some like terms. So when I combine some like terms, that's going to give me I, so those would cancel out. So that'd be 4 plus I. I think as long as I did my work correct. And then just remember, we like to always write our complex numbers as A plus BI in that form. All right, guys, I will come back. I do have a couple more rooms for some questions, but I do want to make sure I get to the rest of these questions. For this one says, I believe that's a negative 16. So I don't really like word problems, but this one was actually not too bad of a word problem because basically the question is going into a rock is thrown upward with a height of 5 feet, which is the initial velocity, which is noted. We have initial velocity, which is 48 feet per second. And then we have our gravity constant, which is going to be a negative 16. So everything is really there. When would the ball reach the 8 feet? And that's exactly like the problem actually I did over here for you, Daniela, is you're going to set the height equal to 5 equal to a negative 16 t squared plus 48 t plus 5. Well, now you're just going to subtract 0 equals negative t squared plus 48t. Well, now in this one, we actually can subtract out a 16t. Actually, sorry. That's going to leave me with a t minus 3. So then we're looking at for when is this ball going to reach a height of 8 feet? And if you were to go and solve for this, you could say, well, t equals 0. That doesn't make any sense, right? That's not going to reach the range when time equals 0, or when t is equal to 3. How is that equal to 0? What did I do wrong? I feel like I did something wrong because that's equal to 5. Okay, well, that was doing the equation. Is it going to equal? Yeah, so we're trying to equal when that's going to equal 5. And t equals 0, t equals 3. I'd have to go and look at the graph to be able to see when this would make sense. Oh, yeah, obviously, when it's equal to, when would the ball eat 8 feet? I'm an idiot. That is, I did that all. I was doing 5 feet, and of course it would reach at 5. It's when does it equal at 8 feet? Right? So exact same thing that I showed you and told you to do. So and then you subtract an 8. So 0 equals negative 16 t squared plus a 48 minus 3. Okay, and you could now look into factoring, or you could look into quadratic formula, but I'm not going to do either of them just because it's late. But yeah, you'd want to be able to check that'd be, I just kind of want to look, 16 t times t. See if anybody sees this. 8t, 2t, then we could do a 4t. Oh, one, that's negative though too. So that'd be negative 48 and positive 3, right? So that'd be 16t minus 48 plus 3. So I'm not seeing 14, 32, 48. I'm not seeing anything that would really work unless you did a 4. No. So let's just use quadratic formula. And unless anybody sees it being factorable, which I'm not seeing. So then I just go through the quadratic formula from there to solve. All right. So the next one, I can't remember what the student was asking, but they're asking like how to like convert these. And let me just kind of go through like, let's just talk about negative 590 because the student was, I think they're asking like, how can I do this easier than the way that my teacher taught it? And I never thought about using that negative way, but it's exactly kind of like this same idea. And the one thing I want you to understand when you're dealing with polar coordinates is remember that the polar coordinates, you got to think of them, or you got to think of this, you know, the r times cosine of theta, sine of theta, right? So r is going to be a scalar because when we look at a polar coordinate, right, we write it as r cosine of theta times r sine of theta. So if you're thinking about r as a scalar, you know that that is going to be changing the direction, right? Because therefore it can be a positive or a negative. Like obviously the angles, like when we're just dealing with a, when we're dealing with an angle, when we are dealing with a distance away from the origin, that's always going to be positive. But when we're dealing with r, like when you think of r as like a radius, it's always going to be positive. It's never going to be negative. But if you think about this as a scalar, as like a vector, we know that can be negative in the negative direction. So the way that I like to think of it, I don't think of it the way that your teacher was taught it, like from the negative axis, but it's the same idea. The way that I kind of think about this is if you were to factor out the negative, then basically what you're basically doing is you have this negative 1 times the, or negative 5. Well, no, my brain is crap. So this is r, which is going to be your, and this is going to be your sine of theta, right? Okay, so let's just kind of go through, let's graph 5, let's graph this. Let's do the positive for a second. All right. So if you're going to do the positive for a second, you would graph 9 degrees like this, and you go, you know, circle 1, 2, 3, 4, 5, right? And therefore, there is that point 5, 9 degrees. Now this one's actually a negative 9 degrees, right? So this is actually going to be down here. So this one point would be 5, comma, negative 9 degrees. So then you got to think like, well, what is this negative doing? Like if we have this negative, like what is that going to do to the graph? And all that's simply going to do is that is just going to reflect about the origin. So I think of this negative, when I think of r being negative, and again, my explanation is just going to be poor for this, and I do apologize. But what I like to think about this is I like to graph the negative version. And then when I reflect the r, then I'm just going to put it back up from here. So rather than graphing it from the x-axis and going in the opposite direction, I just like to graph the original function as it is without it being negative. So I just like to graph 5, negative 90. And then what I like to do is I just will reflect it about the origin, which is the x and the y-axis, to give me a negative 5 being negative 90 degrees. Okay, so because you want to think about that negative, that 5 is this vector, right? And if this is going to be negative, so if r is negative r, that's going to be a reflect the origin. So graph it as it is positive and then reflect about the origin. That's the way at least I like to explain it. For question number 7 says f and g are defined. Another inverse problem. So write down the range of f and write down the range of g. So, oh, here's f of x. Oh crap, I didn't see that. ln of x. Okay, write down the range of f and write down the range of g. Oh. Right, state the domain of G inverse. Okay. Well, the cool thing about this is we know ln of x, or at least you should know ln of x as the parent graph. So that graph has a y-intercept at 1 and a vertical asymptote here, right? So this is going to be f of x. So the range of f of x is going to be from 0 to infinity. It's not defined at 0 because that is a vertical asymptote. For g, that is going to be 2x plus 3. The 2 is going to be like vertically stretched in the graph, but I do know the graph is being shifted up 3, so the graph is going to look something like that. Okay, so the range is basically how low does the graph go, how high does it go, but in this case, it's defined at 3. So we're going to use a bracket, so 3 comma infinity. And then state the domain of g inverse of x. Well, obviously, if you were to reflect this about the y equals x line, then this graph would be reflected about that line, g inverse, or state the domain. Got it. So the domain, the cool thing about this is the domain of my inverse is the range of my function. So for 3, that's going to be the same thing. It's going to be 3 to infinity. Okay, so the domain of your function of your inverse is the range of your original function. So I actually don't even do any math there. I am good to go. All right. See if there's any questions that maybe popped up. Thank you so much. Yeah, I don't know why I'm still going live right now. I got to go to bed and I got school tomorrow. I might just have to hop this up, but maybe let's do 28, 29, and then I got 30. Oh, maybe I can fit in one more. And I'll change those. That's what I'll do. All right. Yeah, I don't have time for 32. This is crazy. What are you doing to yourself, Mr. McLogan? All right. So let's do 28. And then I'll make this 29 and then 30. I think 30 questions is a absolute max. Confused potato. Ooh, do you know any sources to find the answer to my question? I didn't see your question. Oh no, your questions, you're by. Oh no, confused potato. Oh. Not sure what your question was. Sorry, confused potato. But I do see the rest of you that are still on. Thank you so much. Oh, you may be back in. Marcin, Buddy, ABQ King, Sai, Chicaboy, Enya, Vapor, The Nerdy Gamer, Cheese, Khan, do the integration of e to the x, and Earl. Ready. Yes, quadratic formula. You know how much you've helped. Well, I'm very happy to be able to help you out. Marza, you don't want to go. All right. I'm not sure. One sentence only. Can you help me explain why is not a polynomial function? Oh, because it's y squared. You're only going to, I'm assuming it's a polynomial function because you're going to want to be in terms of x. Like x, only one term can be squared for on there, because otherwise it's not going to be a function. If your y is squared, it's not going to pass the vertical line test. So that hopefully can help you guys out. 2 ln of x minus 2 as a single log. I don't know how you do that because the minus 2, if that's not in the argument, you could rewrite that as a ln x. You could write the 2 ln of x minus 2 as a single log. I'm not sure. You could write that as ln x squared minus 2, but I'm not sure what else you could do. Well, I'm sorry, Carlos. I am at my very end. I usually end these live streams at 10 o'clock, so I'm like 300 past here from on there. But, well, sorry, Matthew. From there, try to get to my best for you guys. But yes, I don't have everybody's questions or not be able to answer everybody's question. How do you solve linear equations? Toxic actually went through a couple of those early on the stream. So once I'm done, everything should be timestamped, but you can definitely go back and be able to see that. All right, let's see. I'd like to at least get one more question. Something I can go for you guys. Yes, but I'd like to see what it is. And not as much doing, get some rest. I know I do need to end the stream thing. I live in Florida. Thank you so much. How do you find the continuity of piecewise functions? You're going to test those. I could do that. Could you help me solve? Actually, I don't want, well, anyways, this is another quadratic equation problem. So I'm just going to do this one. Just because this adds into this element that we've been doing, which was a solve. right? Typically you want to solve a quadratic if you can, typically you're going to want to solve a quadratic by factoring. But again, for all solving quadratics, you want to, unless it only has one variable, you want to set it equal to 0. So first thing we're going to do is we're going to expand this, x plus 3 times x plus 3. So we've already done this, so this will be kind of like our theme here. So we have x squared plus 6x plus 9 equals negative 2x. Add the 2x. X squared equal, oh, sorry, not x squared equals x squared plus 8x plus 9 equals 0. Okay, so now that's not going to be factorable. So then you can say, all right, well then a is equal to 1, b is equal to 8, and c equal to 9. So x equals opposite of b plus or minus square root b squared minus 4 times a times c all over 2 times a. So that is your quadratic formula. And we already know our a, b, and c. So now you're just going to plug everything in. So it's opposite of b, so that's a positive 8 plus or minus square roots. Let's see, b squared is 64 minus 4 times 1 times c, which is 9. So that's going to be a 36. So that's going to be 2 times 1. 36, so that would be a 28. So 8x equals plus equals 28 all over 2, I believe. And then now you can break down the square root of 28. This will be fun to review. You can break this down into 4 times 7, which can be broken down as square root of 4 times the square root of 7, which is 2 square root of 7. So 8 plus or minus, let's say 2 square root of 7 divided by 2. Distribute the 2 into both of those. 4 plus or minus the square root of 7. Whew. There you go. You can see I'm kind of going a little bit quicker. Sorry if you are trying to go in for there. And Earl, sorry you're in timeout for 2 times, but hopefully that was might have been needed for a reset for now. And no, I'm not able to do as far as the any implicit differentiation at the time. It's just not something I'm teaching recently, and it's something I'd want to make sure that I am covering, haven't covered recently, so it's been a while, so I need to like refresh my brain a lot more on that. Shouldn't it be 3x squared? Oh, come on. 3x squared. No. Oh, plus that. No, okay, I think we're good. I'm not sure what you're asking about, but I think I did make a mistake unless you guys are good. And I told you it's not a, because you're y squared, I'm not sure I see your name. The reason why it's not because your y is squared. I'm assuming that's what you have. What's the fastest way to solve an inequality with 3 variables? I don't know. All right, so let's go and look at the next one. It says we're having a functions quiz tomorrow. The difference between discrete and continuous functions. Well, continuous functions are obviously functions that are continuous. So discrete functions would be like the step function. So, just go and take a look at that step function. And so that's a step function, versus a polynomial. Okay, so discrete functions are not going to be, we're not going to be looking at their continuity from there. You can think about the, but like a step function would be, something that is discrete, not continuous. And then also have trouble identifying the independent and dependent variables. So independent, those are going to be values that are not going to depend on anything. So you can think about those as like the input or the x. The dependent is those are obviously depend on what is being plugged into the function. So that's the output. Or you can think of those in terms of the y or f of x, right? So that's kind of the major difference there. All right, and then the last question that was submitted was from Alexis, was being able to solve this equation like this. Now, I don't really want to do something like this, but it's been a while, a really, really long time, so I'll try to do my best here. 28, 29, okay, cool. All right, so typically what you want to do is when you want to do this, we got to get rid of the radical. So to do that, we need to isolate the radical. So I'm going to subtract an x, and then I'll have a negative square root of 1 minus x equals negative x minus 5. All right, then divide by negative 1. You get 1 minus x equals a x plus 5. Okay, so now I can get rid of the radical by squaring. Now we got to be careful when we're squaring. We need to look out for extraneous solutions. So I get a 1 minus x equals x plus 5 quantity squared. Let's move it over here. So 1 minus x equals, let's expand that out. That'd be an x squared plus 10x plus 25. Let's add the x to both sides, and let's subtract the 1. So then I get a 0 equals x squared plus 11x plus 24. All right, and now what I'm going to do is look to factor this. What two numbers multiply to give me 24? Looks like 8 and 3 add to give me 11, so 0 equals an x plus 8 times an x plus 3. And then x equals a negative 8 and x equals a negative 3. However, when you plug them back into your equation, you got to make sure that they are going to satisfy them. And that means they're going to make them both true. So let's go ahead actually and check our answer here and make sure these both work. So negative 8 minus a 1 minus negative 8 equals negative 5. So we have negative 8 minus, this would be 1 minus negative, that's going to be 9 equals negative 5. So that would be 3, negative 8 minus 3 equals negative 5. That does not seem to work. So either I did something wrong, but let's go and check the other one. So what about a negative 3? So negative 8 minus 1 plus 3, or minus a negative 3, equals a negative 5. And that'd be 4, so that'd be negative 8 minus 2 equals negative 5. And that does not seem to work as well. So those do not work. So it seems, even though I solved my equation, it doesn't seem to satisfy my original equation. So that's why this would be no solution. Unless I did something wrong, which I don't know. I've done 30 questions already tonight. So, all right. Factor completely by using the remainder for factor and synthetic division. That's kind of weird. Yeah, that's already in factored form, so I would just keep it from there. And thank you for giving me through math class. You're very welcome, Miranda, from there. Guys, I don't know if I'm going to do any more questions, but I do really appreciate all of you guys joining on for my stream, or at least being here at the end. It is the end of the night for me. I have school tomorrow, but y2 minus y1 to x2, that is the channel, that is the thing of slope. Anything else to find the height? Ooh, what was that question? I just want to look at this. What was that question? Oh, I guess I just went away. Can you go over triangle congruency? Because I'm having a lot of trouble in it, and I'm in 8th grade. Yeah, but I'm not really sure what you mean by triangle congruency as far as what you need help with. So just let me know. Let me know from there, and I'll be more than happy to kind of further elaborate for you. Maybe. But guys, I'm not going to be able to get to all of my questions. I think I might have to end this. This isn't 39. That was 29. Oh, I did do it. All right. Yeah, cool. That was it. Cool. Yeah, because I already did my 30 from on there. But just a quick little reminder, guys, unless there's any questions I can add for you, that is not where I actually need to do the math. Well, thank you so much, guys. Callahan, Jamal, Justice, Nick, and Garlic. Thank you so much, guys, for helping me and getting through this. Move the decimal and change the exponential into scientific. Exponential, changing from exponential form to scientific. Yeah, well, my brain feels fried. I just did 30 questions for no good reason, otherwise to help you guys out. So hopefully that was beneficial for you. Just a couple of quick reminders that after the stream is over, I will have timestamps for all of the problems that I solved for you guys tonight. So if you are joining in late and you want to know if I got to your question, then you can go back and look. Or if you're just kind of curious to see what I did solve today, you can go ahead and take a look at those. The other things I wanted to let you guys know about is that you can submit all of your questions to me every single week using the Google form that's in the description. And then I'll try to do my best to answer it for you guys this week. But otherwise, guys, I have school tomorrow. Hopefully you do as well. So get studying, get your work done, and I will see you guys next week. Cheers.